Good morning, dear children. Welcome to this class. Hope you all fine. Last class we completed the chapter 9 rational numbers. Today we are going to start a new lesson, chapter 10 practical geometry. In this class we are going to see some animation videos about that chapter. Please watch carefully and study well. All the best.
Introduction.
Samya, today's storm has uprooted many trees in our locality. That's right, Vineet. That huge tree has been broken in the middle. The broken half, leaning against the boundary wall, makes a beautiful triangle. Great, Vineet. Are you studying geometry in school these days? Yes, Samya. We are learning to construct triangles.
In this lesson, you will learn to construct triangles. Objectives. At the end of this lesson, you'll be able to construct a line parallel to a given line, construct a triangle whose three sides are known, construct a triangle whose two sides and the angle between them are known, construct a triangle whose two angles and the side between them are known, construct a right-angled triangle whose one leg and hypotenuse are known. Construction of parallel lines. Two lines cut by a transversal are said to be parallel to one another if each pair of corresponding alternate interior angles are equal. In the figure, if angle 3 is equal to angle 2 or angle 1 is equal to angle 2, line M is said to be parallel to N. We use a ruler and a compass to construct parallel lines. Draw a long line, M, and mark a point X on it. Mark a point Y some distance above it and join it with the point X. With X as center and any radius, draw an arc to cut line M at point Z and XY at V. With Y as center and same radius, draw an arc PQ to cut XY at point U. Measure VZ with a compass. With U as center and the measured radius, draw an arc to cut arc PQ at S. Join S and Y and extend it to form line N. Measure alternated interior angles SYX and YXZ. Angle SYX is equal to angle YXZ. Therefore, N is parallel to M. Construction of triangles. A triangle is a two-dimensional plane figure made up of three sides and three angles. We can construct triangles if we know three sides, SSS, two sides and the angle between them, SAS, two angles and the side between them, ASA, right angle, hypotenuse, and one side, RHS. Let us learn to construct all four types of triangles. SSS criterion. Let us draw a triangle whose three sides measure 4 cm, 5 cm, and 6 cm with the help of a ruler and a compass. Draw a line segment PQ 5 cm long. With point P as center and a radius of 4 cm, draw an arc. With Q as center and a radius of 6 cm, draw another arc to cut the previous arc at point R. Join points R and P. Join points R and Q. Triangle with sides 4 cm, 5 cm, and 6 cm is drawn. SAS criterion. Let us now draw a triangle whose two sides measure 4 cm and 5 cm and the included angle measures 30 degrees. Draw a line segment PQ 5 cm long. Measure 30 degrees with Q as the center of the angle and mark the point as S. Draw ray SQ by joining points Q and S. With point Q as center and a radius of 4 cm, draw an arc to cut ray QS at point R. Join P and R. triangle PQR with two sides 4 cm and 5 cm and one included angle 30 degree is constructed. A as a criterion. Let us now draw a triangle, two of whose angles measure 40 degree and 80 degree and the side between them measures 5 cm. Draw a line segment PQ 5 cm long. Measure 40 degree with point Q as the center of the angle and mark the point as S. Draw ray SQ by joining points Q and S. Measure 80 degree with point P as the center of the angle and mark the point as T. Draw ray TP by joining points T and P. Mark the point of intersection of rays SQ and TP as R. Triangle PQR with two angles as 40 degree and 80 degree and the side between them as 5 cm is constructed. RHS criterion. Let us now draw a triangle one of whose angles measures 90 degree and the base and hypotenuse are 8 cm and 10 cm respectively. Draw a line L. Mark a segment AB 8 cm long. Draw a perpendicular AG to AB at point A. With B as center and a radius of 10 cm, draw an arc to cut AG at point C. Join point C to point B. Right-angled triangle with a base and hypotenuse measuring 8 cm and 10 cm respectively is formed. Self-assessment. Match the criteria for drawing triangles with their description.
In earlier classes, we have become familiar with number of shapes. We have learnt to draw some of them. For example, to draw a line segment of given length, a line perpendicular to a given line segment, an angle bisector, a circle, etc. In this chapter, we will study the following concepts: construction of parallel lines, construction of triangles. In this concept, we will discuss about how to construct a line parallel to a given line from a point outside it. Steps 1. First we take a line L and a point O outside L. 2. Now we take any point A on L and join A to O. 3. With A as center, taking some convenient radius, we draw an arc cutting the line L at C and OA at D. 4. Now with O as center and taking the same radius as in step 3, we draw an arc PQ cutting OA at D. 5. Now we place the pointed tip of the compass at C and adjust the opening so that the pencil tip is at B. 6. With the same opening as in step 5 and with D as the center, we draw an arc cutting the arc PQ at E. 7. Now we join OE to draw a line M. Here we will learn to construct parallel line with the given distance. Draw a line PQ. Draw a perpendicular on the line PQ which intersects PQ at O. Using compass with O as center, mark x centimeter on the perpendicular line as O'. Draw a perpendicular on the point O'. Name this line as AB. Therefore, line AB and PQ are parallel lines.
Geometry. Action of triangle when length of all the three sides are given. Construct triangle XYZ in which XY is equal to 4.5 cm, YZ is equal to 5 cm and ZX is equal to 6 cm. Before starting our construction, we will draw a rough figure from which we will get an idea on how to proceed stepwise in our construction. Step 1. From the rough figure, it is clear that first we have to draw a line YZ of length 5 cm. Step 2. From Y, point X is at a distance of 4.5 cm. So, with Y as center, draw an arc of radius 4.5 cm. Step 3. From Z, point X is at a distance of 6 cm. So, with Z as center, draw an arc of radius 6 cm. Step 4. X has to be on both the arcs drawn. So, it is the point of intersection of arcs. Mark the point of intersection of arcs as X. Join XY and XZ. Triangle XYZ is the required triangle as shown in the figure. Construction of triangle when length of two sides and included angle is given. Construct a triangle ABC in which angle B is equal to 60 degree. AB is equal to 4.8 cm and BC is equal to 5.2 cm. Before doing construction, draw a rough sketch so that you will get an idea which side is to be taken as a base. Step 1. From the rough figure, it is clear that we have to draw the base first. That is, OX is equal to 4.8 cm. Step 2. With O as center and of any radius, draw an arc cutting OX at A. With A as center and with same radius, draw another arc cutting the previous arc at B. Step 3. Join OB and produce it to get a ray OY. Angle YOX is equal to 60 degree. Step 4. Take the compass and measure 5.2 cm using a ruler. Taking X as center, cut an arc on the ray OY. Step 5. Join Y and X. Triangle YOX is the required triangle. Construction of triangle when measure of two angles and length of included side is given. Construct a triangle APB in which PB is equal to 6 cm, angle P is equal to 60 degree and angle Q is equal to 60 degree. Just as what we did in the previous construction, here also we will draw a rough sketch of the triangle. Angle P and angle B are the two given angles and PB is the included side. We will always take the included side as the base. Step 1. Draw a line segment PQ is equal to 6 cm using a ruler. Step 2. We need to draw angle P as 60 degree. With P as center and of any radius, draw an arc cutting PQ at B. With B as center and with same radius, draw another arc cutting the previous arc at A. Step 3. Join PA and produce it to get a line PR. Angle RPQ is equal to 60 degree. Step 4. Now, repeat the same steps with Q as center. Suppose the intersection point of PR and QR is X. Then, XPQ is the required triangle. Construction of a triangle when base and base angles of an isosceles triangle are given. Let us construct a triangle having XY and XZ as equal. Base YZ is equal to 6 cm. and angle XYZ is equal to angle XZY is equal to 45 degree. Step 1. Use ruler and draw a line segment OB of any convenient length as shown on the screen. Step 2. Now use compass and open it to any convenient radius, and with O as center, draw an arc which cuts line segment OB at X. Step 3. Again use compass and open to the same radius as of step 2, and with X as center, draw an arc which cuts first arc at D. Step 4. Again use compass and open to the same radius as of step 2, and with D as center, draw another arc which cuts first arc at C. Step 5. Again use compass and open to the same radius as of step 2, and with C and D as center, draw two arcs which cut each other at E. Step 6. Join OE and extend it to A as shown on the screen. Above formed angle AOB is equal to 90 degree. Step 7. Now to construct at 45 degree angle, we will construct the angle bisector of above angle AOB, and it's done in the following steps. Again use compass and open it to any convenient radius, and with O as center, draw an arc which cuts line segment OB at P and OA at Q. Step 8. Again use compass and open to same radius as of step 7, and with P and Q as center, and draw two arcs which cut each other at point F as shown on the screen. Step 9. Join OF and extend to E as shown below on the screen. Step 10. EO is the bisector of angle AOB. Therefore, angle AOE is equal to angle EOB is equal to half of angle AOB is equal to 45 degree each. Now, with B as the center, repeat all the steps and draw an angle of OBA as 45 degree. Join OBH and the triangle OBG is the required isosceles triangle. Construction of an isosceles triangle when equal sides and an angle is given. Step 1. Draw a line segment which will become one side of the angle. Set the compasses on P and set its width to any convenient setting. Draw an arc across PQ and up over above the point P. Without changing the compass's width, move the compasses to the point where the arc crosses PQ and make an arc that crosses the first one. Draw a line P through the intersection of the two arcs. The angle QPR has a measure of 60 degrees. Measure 6 cm with the compass on a scale and cut an arc on PR from Q. It will meet at point M. MPQ is the required isosceles triangle with 6 cm on two sides and 60 degree angle on one side. Construction of a triangle when two sides forming a right angle between them are given. Construct a right-angled triangle APB with PA is equal to 4 cm and PB is equal to 6 cm and angle BPA is equal to 90 degree. Step 1. Draw the base PA is equal to 4 cm with a scale. 2. At point P, let us draw a right angle APB that is 90 degrees. Place the point of the compass at P and draw an arc with any radius that passes through PA and name it Q. Place the point of the compass at Q and draw an arc of radius PQ at R as shown. Now keeping the compass at R, cut an arc S with the same radius as shown on the screen. From the point R, with the same radius, cut an arc above P. Place the compass at S and cut an arc above P, intersecting the arc cut in step 6. Name this intersecting point as T. Now join T to P. The angle APT is 90 degree on PT with 6 cm measure and name the point as B. Join B to A. This is the required triangle APB with 4 cm and 6 cm sides and angle P is equal to 90 degree. Construction of a triangle when one side and hypotenuse of a right-angled triangle are given. Construct a right triangle PQR in which angle Q is equal to 90 degree, PR is equal to 6 cm and QR is equal to 4 cm. Step 1. Draw QR is equal to 4 cm. Step 2. Name the intersecting point of these two arcs as C. Join AC and BC. Thus, an equilateral triangle ABC is formed.
Summary. Let us summarize what we have learned. Construction of a line parallel to a given line. Construction of a triangle whose 3 sides are known. Construction of a triangle whose 2 sides and the angle between them are known. Construction of a triangle whose 2 angles and the side between them are known. Construction of a right-angled triangle whose 1 leg and hypotenuse are known.